So we want to look at inverse relationships, and then specifically if those inverse relationships are actually functions, and how different graphs have this. And we'll look at both coordinates and we'll look at graphs as well. So the idea of looking at an inverse, if we want to think of notation, first of all, we're going to write inverse functions or inverse relationships as to the -1 power, right? And so when we think in general of a function, and how do we find its inverse, one thing you can do is really just to switch the x and the y value. If it's a coordinate, all you have to do is reverse those. If it's a table of values, you just switch the x and the y values, and that is the inverse of that relationship. Okay, so again, think of, you take 2 and square it, you get 4, but then if you take the square root, you get back to 4 or back to 2. Those are inverse relationships. So in general, we're interested in, is the initial relationship, is it a function? We're also interested in if the inverse is a function as well. So if that's true for both of these, we refer to this as a one-to-one relationship. So we're going to make sure, first of all, that whatever relationship we're looking at, whether it's a graph or a set of coordinates, we're going to make sure that that's a function. And then we're also going to make sure that when we look at the inverse of it, so we switch the x and y values of everything, we're going to make sure that it is indeed a function as well. So these are going to be the things we're looking for. We're going to go through a few examples, and then you'll get a chance to practice that. So looking at example 1, we have a few coordinates here, and the first thing we want to do is we're going to recall that in order to have a function, we would need to make sure that every input has exactly only one unique output. Okay, and I always think of a vending machine. Make sure that every time that you push a button on a vending machine, that you get exactly that item. If you were to push the same button on a vending machine, and let's say the first time you push that button you get a Snickers bar, and the second time you get peanut M&Ms, you're without knowing, you're going to be, something's messed up here. Every time that you press that button that says Snickers bar, you should get a Snickers bar, right? And so we want to think of that, and so we're going to, if we recall that, that will give us an idea of how to identify if its inverse is also a function. So the first thing we want to do is look at the inverse of these coordinates. So we're just going to reverse them. So instead of 1, -2, we're going to do -2, 1. And instead of 2, 4, we're going to reverse the x and the y coordinate, and we get 4, 2. And so you see that we could do that for the rest of these coordinates. So then the question is this a function? And if you look carefully at the original coordinates, the inputs are 1, 2, 3, 4. So, or the x values. So clearly that is a function. Now, if you look closely at the inverse, you'll notice that that this is not a function. And the reason is because if you look closely, both of these inputs are -2, and in the first coordinate the output is 1, and in the second output the output is 4. And so because those are different, they should have been the same if it was a function. They should have been the same output. Okay, so clearly then R is not a one-to-one function because the inverse is not a function. We need 2 yeses in order for this to occur. Okay, so if we look at the next one, again, I'm just going to find the inverse of these coordinates, and again, just switching the x and y coordinates here. And we're going to look first of all and see, okay, is the original a function? Again, if you see this, the answer is no. And if you look closely, that's because, again, we have the same two inputs, except that the outputs are different. And that can't be a function. Now, if you look at the inverse of the coordinates, these actually are functions. Okay, because notice that all the inputs are actually different, so there's really no opportunity for that. But however, because the first relationship is not a function, remember they both have to be functions in order for it to be one-to-one, is what we refer to as one-to-one. Okay, all right, and then another way that we could show this is with these arrow diagrams. And again, just think of if you think about the coordinates there, it would go 0, 6, 11, 6, and 1, 2. So there's three coordinates being described there, or three relationships being described. So clearly, from the idea that we have two of these functions pointing to 6, that's actually okay, right? Because think of a vending machine where you have two buttons that both give you, for instance, Diet Coke. That would be okay. A vending machine would work properly with that. And so this is a function. But if we go ahead and reverse these directions, and so if we go from 6, 0 and then 2, 1 and 6, 11, again, notice that even though the first one is a function, the second one is not. And so that tells us that, again, this is not one-to-one. So you're going to be looking for functions if they are one-to-one, and then also the inverses if they are. I'm sorry, if the relationship is a function, if its inverse is a function. If both of those are true, then it is one-to-one. So not only can we just evaluate coordinates, but also we can think about these as the graphs of these relationships as well. So if you have a continuous graph where it's not just individual points, but it's an entire graph, we can also look to see if we have a function. Remember, we have what we call the vertical line test, which means that if you draw a vertical line at any point along the graph, if it crosses in two places, it's not a function. And so in the same sense, then, if you think of the inverse, if you were to do a horizontal line test, that would tell you whether the inverse is a function. So let's take a couple examples here. We're going to look at these two graphs, and we want to know, are these graphs one-to-one? That means, again, that they both need to be functions. And if it's both, the inverse needs to be a function, and the original graph needs to be a function as well. So if we think of the vertical line test, on the first one, yes, the graph is going to, you don't cross it at any point twice. And so, yes, the function is the original relationship is a graph, or is a function. And if you think of the horizontal line test, the inverse is also a function. And so this graph right here, this linear equation, is a one-to-one, because both the original graph is a function and its inverse is a function. Okay. All right. So they both need to be functions. Okay. And then now, if you look at the other graph, notice that if we do a vertical line test, clearly that function is, or that graph is a function. However, if you draw a horizontal line, notice that it crosses in more than one place, which means the inverse is not a function. So this is going to be a no, which means that it is not one-to-one. So that is the way that we identify whether a function is one-to-one or not, is that we need to know, is the inverse a function?